Assalamu alaikum. For the today's lab session, the first command that I will be demonstrating is the blend command. In the previous lab session, we have covered swept blend command and types of simple sweep and helical sweep, and what is the difference between swept blend command and the simple blend. As the word blend actually literally it means mixing. Blend means mixing of some part into another part. So swept blend actually means, as I had already told in the previous lab session, that this command swept blend is actually a mix-up command for simple sweep and the later this command blend command. So this is actually a combination, means the trajectory is actually extracted from the concept of simple sweep command, and the blend is extracted from this blend feature. So swept blend actually requires means multiple cross sections of different sizes and different geometries will be blended into each other following a given geometry, which is actually the basic requirement for the sweep command. So actually blending means the various cross sections are blended into each other. For example, one might be a circular cross section and other might be a rectangular or square cross section whatsoever, or any other polygon or a point section. So that means actually blending. And swept means that a trajectory is required, and that trajectory, the cross section will be following that trajectory. So the blend command is actually literally it means that it actually does not require the trajectory. So trajectory will be vanished in this command and only the cross sections will be there. So it is in some way more complex or advanced command as compared to the swept blend command, because swept blend command at least requires two cross sections, one on the either end of the trajectory, but the blend command does not require any trajectory. This command has the cross section can be drawn either internally or externally. So let us first try and demonstrate it using internal sectioning. So directly click on blend command, and now as you observe that in the type option the solid is actually selected, and in the blend using sketched sections and selected sections. So here the important thing, as I have already told, that sketched sections means internal section and selected sections means the sections have been defined externally using datum sketch command, and they can only be selected, means the sections are pre-existing. So here, just like the swept blend command, here the sections first tab is the section tab. So in the section tab, as you go and here you observe, here it are two radius, that sketch sections and selected sections, and by default sketch sections is actually selected. So that means first section is ready to go. So in the section 1, so it says here now define. So defines mean a section will be internally defined. So just click on define, and now you will be clicking some plane here. So let us first place these planes into the isometric mode. So go into file, into options, and into options. After that you go to model display, and from the menu select on isometric and just click enter here, sorry, apply, and click on enter, and in the options dialog click on no. So here you will be selecting, for example, you can say this right plane. For example, I have selected. So first section, for example, you can say that it is, for example, a simple circle. So let us the next section, for example, so just click on OK, just finish this section, and now it says that section 1 actually a circle has actually 2 number of segments, so the next section will necessarily be consisting of only 2 segments. So for example, I place further 2 sections, and both are the point sections. So here it says sketch plane location defined by offset dimensions and or reference. So offset dimensions means that the plane for the next section, this is section 1 plane which you have actually created in this right plane. So this is actually showing the distance from this plane. So this plane, for example, I can say this is some suitable distance, for example, say it to be 150, for example. Just observe it from the you can say front view here, like this. So this is actually showing the true distance here, 150 units from this plane. First section was in this plane, and so this is the displacement from that plane, that is 150. So now the second section plane will be located up here. So now when you have placed the reference of plane using offset dimension, now just click on sketch here, and here you can observe that this plane you are actually observing the edge of the plane. So just click on sketch view, and here you will be observing if you so here. So now what you can do, for example, I place the next section, just for example you can say the point section, this construction points. So for example, I am placing the point section here like this, and I'm just clicking on OK, and here you can observe here the situation like this. So in this way, for example, this model has been generated. So let us use some different type of section. For example, I am just clicking on editing, and I am deleting removing this second section, and I am actually editing the first section to, you can say, create some more segments. Click on sketch view here and use the divide tool. For example, I am dividing it into this is 2 segments, now 3 4. For example, there are total 4 segments, first segment, second segment, third segment, and 4 segments like this. And here you can observe there are 4 segments. Here the important thing you actually observe that whenever you draw a complete circle without using the divide tool, it actually lists here 2 number of segments, because one is the circle center and other is its boundary. but when you divide it in 4 segments, so you may expect that there might be you can say 5 number of total segments, but it's lists here 4, because actually at that time it omits the center of the circle. So the next section, for example, I am using that might be a rectangular section. So let us first define the location of the next circle. So in the standard rotation, as you can observe here, so for example I am increasing its distance, for example here some random distance, and here in this plane the next section will be generated. So let us, for example, I am using this center rectangle here, that might be any location anywhere. So for example I am just placing here the location, and now I can if required I can just rotate it to some angle, just, and this is optional, just, and now click on OK, and here you can observe that this section has been placed and model has been created. So let us add another section here, a third section, and now this will be the location from the second section. So the second section was here at this location, so this is the third section. So now click on sketch here, this is random distance I am selecting. So again, for example, I can say, for example, I am creating an elliptical section here. In this plane, the section can be at any location here, like this. So let us, now you can observe that it will have to be divided into 4 number of segments again, and here you can click on OK, and here you can now observe like this. So actually you can use as many sections as required. So this is a very important command in this respect. So let us now you can, for example, use the last section or the fourth section to be as the point section on this side, because the sections will be orderly arranged. And now click on sketch. For example, I am using it much larger distance here, like this. Click on sketch, and just for example click on point section here, and now click on OK. So now you can observe here that the object like this has been generated. So as you can observe, this is a very complex command, and such model cannot be created using any other command. So this is a simple demonstration for the simple blend command internally. So let us now demonstrate the blend command using external sketching. So let us delete this command, and now if you want to demonstrate this command, blend command using external sketching, so what you will have to do, you will have to create as number of datum planes as the number of sections required for the blend command. So for example, you are creating datum planes parallel to this right plane at the locations where the sections are to be located. So click on plane here, for example this is the right plane, right plane. Just go into editing here sorry, and here now change the distance. Better you look it from the top so that you get the true displacement. So at this location. This is the random displacement here, that can be on either side. For example, here this is the location for the next section. So this plane will be defining the location for the next section. So click on OK here. So here at this stage, two sections can be defined. So let us create a third plane, for example, at some given distance from this plane here, like this. That can be any random distance here. So click on OK. So you can use a third plane as well, sorry, a fourth one, if you want to use 4 cross sections like this. So let us now create actually sketches externally in these planes manually. So these actually section will be independent of the command later on, for which they will be applied. So one important thing that you must note, that here you cannot use or create the point section when you are demonstrating this command externally using external sketching. Means if you want to use point as the section, so you must demonstrate this command internally using internal sketching, using the sketch sections feature. So at this stage I can say, for example, I am just creating a circle here at this location. So again you will have to divide the circle into as many number of segments as required, as the number of section in for the section which is actually containing maximum number of segments. Like for example, this rectangle is actually consisting of 4 number of segments, so this circle must be divided into 4 number of segments. So if instead of this rectangular section I had, for example, used some pentagonal or hexagonal section, so then this circle would require 5 or 6 number of segments. So just click on divide tool, for example, here, and click on random points here, and as you can observe, now 4 number of segments have been placed. And furthermore in this plane, so just click on OK. This section is OK, and after that the next section, for example, click on sketch and select this plane, and here for example now you can create, for example, an ellipse, just a random location here, that can be at any location. Now again you will have to divide this ellipse into 4 number of segments. So click on OK. So now you will be clicking on this next plane, and let us create just you can say center rectangle here at any location here, any suitable size, because this is a freehand shape. Now you can, for example, again create some circle, for example sketch, and use this plane as sketch, and click on here, just for example create a circle again, and click on this divide tool command here, click into again 4 number of segments. These number of segments must be equal in number, but their length cannot be equal, it is not necessary. So click on OK. So you have created 1 2 3 4 number of sections. So let us now, you will be demonstrating the blend command externally. So now first of all check this reduce selected sections, and here section 1 here, for example you can start from any location here. For example you can say you are starting from this section, and after that you will be clicking on add, and after that this section like this. So it is very important here you are observing this point. This point is actually if for example you will be clicking on at this point, so that means this point, this location is actually connected with this location here. You will be observing very important thing. Remember this location, this white dot here. So if you click on says, that means that white dot actually has been connected with this corner. So if you just you can say LMB, left mouse button, press and drag here and bring it here. So here you will be observing that this point has been directly connected with this point. So again, if I am moving here by pressing and dragging here at this location, so you will be observing that that point has actually connected with this. So in this way you can actually control this shape. So this is very important thing here. For example, in section 1, so here if you can would have clicked here like this, so in this way you can actually control this section. So this is a very important demonstration, and I hope you have understood this important feature like this. So in which section you want to modify this point, you can move it according to your own requirements. Here just LM press and drag like this, so you will be demonstrating. So it is important that some time your command might look failed, so you will be actually modifying this point or moving this point like this, so the command will be successful. So now let us add the third section, and now click on this, like you can observe. So again here you will be modifying using this point here. For example, you can click on it here, so like this. So actually here the model is more distorted, so bring it back here again. For example, I am sorry, for example again put on section 2. For example, I am moving this point from here, so here you can observe that the shape of the body is actually changing. So now observe here like this. So in whichever the section, so in this way you can control. So this when I have placed the this white control point at this location, the model is more distorted and practically it is impossible. So you can move it here like this. So this is okay. Here at this location it is also okay. So in this way you can control the sections like this. So now let us add the fourth section and click on it here, as you can observe here. So in this way you can create freehand shape like robots or human hand, for example human head, and many you can say organs and various very important complex shapes using this feature. So I hope you have understood. So this is actually the simple demonstration for the blend command using external and internal ways. So this has been demonstrated. After that, leave the rotational blend for the time being, and the next important commands are in the engineering area. So let us demonstrate those commands. Sorry, though now in the engineering area, so let us demonstrate some more commands here. So let us delete this model. Now in the engineering area, remember, when there is no base model, means there is no extruded or some model is existing, so all the commands in the engineering area are unavailable, because in the engineering area the commands are actually the modifying command, like means a hole can be created only if there is some model, because hole cannot be created in some empty space or empty model. And similarly the edges of some existing model can be rounded, so round command is also in the engineering area. So in the engineering area we can observe that various commands in the editing and engineering area are unavailable as soon as the model is not available. So let us first create a simple model here. For example, like using the extrude command internally, you can say in the placement tab here, just click on sketch, click on define here. For example, create a random, you can say center rectangle, just for example you can use it here, and create this random rectangle, click on OK, and here for example just create simple cube like this. And now you can observe various commands in the engineering area are available. So first of them is the whole command. So actually the whole means here the engineering holes are actually created, means for example here you can observe here in the whole ribbon or dashboard interface of this command, that in the type there are two types of the hole command. One is simple hole and other is the standard hole. So in the profile there are three options. One is flat, drilled and sketched. So we will only be observing flat and drilled hole, and after that in the size here, and that these are first option. And here in the placement tab, the first important thing is type is linear, that is all okay, and after that is placement. So you will actually be clicking in the placement area. This is the placement area. So remember, for the whole command we actually require two types of faces. One is called the placement face and other is called the offset references. So actually placement and offset references are actually the faces of the model, various faces of the model. So placement face actually is that face of the model at which you can say that the placement face is that face of the model that the axis of the hole will be perpendicular to that face. Mean hole will be located in this face such that the axis of the hole will be perpendicular to this face. So if you want to place the hole in this face, so you will this will be the placement face. If you want the hole to be placed in this face, so this will be the placement face. If you want the hole to be placed in this face, so this will be the placement face. Means whole axis will be perpendicular to this face. So let us demonstrate it. So for example, this is the placement face carefully. So here you can observe that here are actually these two circular radius actually showing the height of the hole, and these two actually grip points actually, and this is actually showing the center of the central line of the hole. This so placement has been completed. After that, very important thing is you will be clicking on this area. You will not just simply be clicking randomly at this face. So if instead of clicking in the offset references, I can just click on this face, so I can observe that this will become the placement face, but I want this face to be at the offset reference. Again, if I am without clicking in the offset references area, I simply click on this face, so this has become now the placement face, but I want this face to be as the offset reference. So that means, for example, this is actually my placement face. So I will have to first click in the offset references area here like this. After that, what we will be doing, we will be actually defining two offset references. Offset references are actually two faces which are perpendicular to each other, but they are actually not including the placement face. They are other than the placement face. So placement face cannot be the offset reference. So remember, this placement face or any face parallel to this face, means the placement face or any face parallel to this top face, because this is the placement face, cannot be the offset references. So other faces which are perpendicular or surrounding that placement face can be the offset references, and offset references can't be more than 2. Remember, offset references can be the offset can be perpendicular faces, two offset faces. Offset reference can be faces or can be edges as well. Can be edges as well, means this edge can also be the offset reference, this edge can also be the offset reference. So this is very important thing. So first click on, for example, you want this face as to be the offset reference, so click on here. So here you can observe that this face has been fully defined here, this dimension randomly, and after that it says that select one item is select the other face. So you will normally wouldn't be able to select the other face unless you press the control button from keyboard. So simply press the control button from keyboard first, and now click on this face, for example. So this is the second offset reference, and now you can just move this central location of the hole. So after that you will be observing, so this hole is now defined. After that the next requirement will be the size or diameter and depth of this hole. For example, go into the shape area, and here you can observe here this is actually, this is showing the preview of the hole. So the diameter for this hole is 0.47, which is very less. So here you can, for example, put it here, for example 20, for example, randomly. So you will be observing the diameter will be increasing. So let us make it 200, for example. So here you can observe here, so that is sufficient. So a hole of diameter 200 units have been randomly created. So if here this is the blind hole, here you can observe, and if you click on it here, for example you select on throw all, so this will be the throw out hole. So just click on OK, and now here, for example, you are clicking on from top, so you are observing this is a throw out hole which I have randomly placed. So for its correct location, you can simply go into the, you can say the definition of the hole, and here if you know the, you can say the height and width or these dimension, that how much is the length of this edge or this face and how much is the width of this face. So you will be using half of this dimension and half of this dimension as the location from this center. So this hole will be located in exactly at the center of this face, or any other location where you want this hole to be. So this is quite random. So here you can change any random distances here if you are creating this hole with using known dimensions. So this is the way. So this is a type of simple hole, and it is a flat hole. Flat hole actually you can observe, flat hole means, for example, I am using a blind hole here. You can say and go into the shape area. If I am again clicking on it here and I am using blind, so blind means limited hole which is not throughout. Blind means for example, this is the total thickness or depth of the model. So hole on the bottom of the hole will be limited, means will not be throughout hole. So for example, I can better observe it here like this. For example, if I am observing it from the front view, for example here, so this is actually showing the depth. Or in a more better view, we can, for example, click on it here in the wireframe mode. For example, here just click on it here in the wireframe mode. So you are observing it here that this is actually showing the depth of the hole. So if just click on it here, so here you can observe that this is actually the depth of the hole. And if you observe it from the, you can say, front top view, so here in the shading you can observe it here. So this is actually the bottom face of this hole, so in this way. So this was actually a simple demonstration for the simple type of hole here, simple and flat hole. So if I click on just drilled hole, so drilled hole means because the drill bit is actually a conical shape. So here we will be observing, if you observe it from the, you can say, front view, so here you will be observing that the drilled hole will be created. So how the drilled hole will be created, if you just click on OK, for example, so here you can observe a conical tip. For example, if you observe it in the wireframe mode, so here a hole like this means this is actually a conical hole, mean because the drill tip will be at this location. So means this is the drilled hole. If we are creating this hole using a drill, so this will be the drill diameter, this will be the drill diameter, means the hole dia will be equal to the drill diameter. The hole diameter will be equal to the drill diameter, and this will actually be the conical or the drill bit angle. So in this way, this is a conical shape. So a conical hole will be created. So this is the drilled hole type of that means the profile for the hole is drilled. Flat means the bottom is a flat, mean a circle, and the type is simple. So the simple type of hole has two types of profiles. Two types of profiles are two, means one is flat bottom hole and other is drilled bottom hole. One is flat bottom hole and other is drilled bottom hole. So leave this sketched option, and after that the important thing is countersink and counter bore holes. So this is also very important. So that is a simple demonstration. For example, if I use the countersink hole, so here you can observe that the countersink hole are such that you can observe it here. If you observe it in the shading area like this, and you can better observe the shape of this hole here, means they have actually the for the seating of conical heads screws, they can be well fitted. And this is actually the hole dia, and this is actually called the countersink dia. And countersink dia means the maximum dia of this countersink is actually 240. So you can preview or change the dimension from this preview, and this is actually showing the depth of the hole. This is actually showing the depth of the hole. This is the depth of the hole. So this is actually between these two arrows, this is actually showing the hole dia, and this is actually the top dia of this countersink. This top dia is actually showing, and this is actually the countersink angle, and this is the drill angle. As you have already observed that this is the drill bit angle, this is the drill bit angle. So these are all the types of the drilled hole are countersink and counter bore. Means the sub types for the drilled hole are counter bore and countersink hole. So remember, if I am now clicking on the counter bore hole, so countersink will not be deselected. So let us first deselect the countersink hole, otherwise a mix-up hole will be created. So first click on this countersink hole, and now click on counter bore hole, and here you can now observe that this is called the counter bore dia. Means this is the counter, this is actually used for the flesh or heads. So here, as you can observe, this is actually the total depth of the hole is 213. So here, as you can observe, this is the counter bore dia. By default is actually 220, which is actually wrong. So here you can use, for example, you can use, for example, 50, just 50. So here you can observe, this is actually the counter bore depth. Counter bore depth is 50. Counter bore dia, this is 360 is the counter bore dia. So you can change it here like this. For example, if you are decreasing it, for example, you can say, and remember, counter bore dia must be greater than the 200 hole dia. Hole dia if 200, so that means counter bore dia must be greater than 200. It cannot be less than 200, obviously. So for example, I can make it, for example, 250. So you can observe it here like this. So this the diameter has been reduced, and similarly this counter bore depth, for example, I am making it 20 units. So here like this, in this way this hole will be generated, and other things are quite simple. So counter bore countersink hole has been actually fully explained, and there is nothing more. So actually what you will be remembering, that in the simple type, the profile has two types. One is the flat bottom hole, and other is the drilled bottom hole. And in the profile options of the drilled hole, there are further two subtypes. One is called counter sink hole and counter bore holes. So other in the body option there is nothing like, and in the property just you can rename it and click on OK, and in this way the simple demonstration has been created for the. And the next command is actually the round, as the name indicate, that is quite simple. So it is actually round the edges. So click on round command and just click on it here, for example, at one time, and here you are observing there are two control points like this. So you can just drag it here, and here you can observe this is actually the radius. You can change it from here. So 90, for example, you can make it 80 or any random radius. So at one time one set has been created. If you want to create the next new set, so you can click on new set, or you can just click on this edge, for example. So this edge by default it is actually picking the same radius. For example, I am making it, for example, 40. So here in this way you can create as many edges as required for the round option. So just click on it, OK, and you have observed that the two edges have been rounded. So you can round as many edges as required. The next is auto round, so leave it here. And the next is the chamfer command. So the chamfer command is actually the edge chamfer and corner chamfer. So edge chamfer and corner chamfer are simple. Edge chamfer, as the name indicates, it is just like the edge round, means just you can simply click on for example, click on edge chamfer and click on this edge, for example. So you can observe it here. If you look it from, for example, in the top view, so here like this, means this is random. So let us, for example, I am just cancelling this command, for example, and I am deleting this round command here. So now click on chamfer, for example, I am chamfering this edge. So here you can observe that by default, and remember this chamfering option has many types, dimension scheme. For the chamfer command is one is called D cross D. So D cross D means D is actually, remember, the distance from this parent edge, to the existing location of the chamfer at this face end. So here dxd means both chamfers are distances from this edge are equal. so that means a 45-degree chamfer automatically, because this dimension and this dimension is same, so that means this is actually creating an isosceles triangle, because this side and this side along with this edge is actually creating d cross d chamfer. So if I am using this, for example, d1 cross d2, so that means the chamfer distance can be independently controlled. So this is actually a simple demonstration. Like this you can actually change logically. After that, there is angle d. So angle xd means the chamfer distance at one face will be located by the angle. So you can observe it here that this is actually the angular option. Like this is the angular control, means this face is actually being used as the reference for this chamfer angle. So this is actually this is actually showing the distance from this edge, means this edge is actually showing this distance. This distance is being defined using the angle option, this angle, and this edge, as you can observe it here, this edge is actually showing this is the d distance. This is the d distance as 190 is shown here. So like this, and the next option is actually 45 cross d. So that means automatically just like d cross d. So d cross d and 45 cross d are actually alternate and equal options, because 45 cross d means that the distance along one chamfer is d. So the angle for the other chamfer distance will be defined by 45 degree. So that means equal chamfer, because the angle is 45 degree. So that means isosceles triangle in a similar manner as d cross d. So this is also quite simple. So you can create. So if you want to create a new set having different dimensions, so you can control it independently. So these are actually quite simple demonstrations. So I have told you, you can try it yourself. So this has also been created, and leave the corner chamfer. For example, corner chamfer, it is quite simple, that if you click on a corner, for example, I am just you can say just as a contribution, for example, I am deleting this chamfer, and for example I am applying corner chamfer at this corner. So click on here like corner chamfer, and here click on this point, so you can observe it here. So this is also a very important feature. So like this corner chamfer can be controlled, means because at the corner actually three edges are actually meeting. So in this way the complete corner can be independently controlled. So this is the demonstration for, and till here very important commands have been completed. So now let us demonstrate further commands. The next important command is actually the draft command. This is very interesting and very important command, means these three commands, draft, shell and rip, are very important command, and these are actually covering the core portion for these 3D features. And let us demonstrate some of them in this lab session. So let us, for example, I am deleting this corner chamfer, and again for example I am deleting this hole as well. So the draft command, actually means the edges the faces will be drafted. Drafted means the slanted edges at some angle can be created. So that is actually the purpose of drafting. Drafting means the angles, the faces can be slanted or can be tapered at some given angle. So drafting is very interesting and important command. So click on draft command here, and here you can observe it here. This is the here in the references area. This are actually detailed options, and one is first area is actually the draft surfaces. So remember, the draft surfaces actually are the number of faces, at least one face, but there can be more than one faces. There can be more than one face. So at least one face must be there. So for example, I am using this face. This is actually the draft face. This is one face. So I can, for example, also select this face, but prior to selection of this face as to be the draft face, I will have to press the control button. Remember, for example, I'm selecting the control button from keyboard. So here you can observe it here, the details. In the details you can observe it here that you have selected two faces like this. So click on OK. So after that you will be clicking on this area in the draft hinges area. Remember, so you will actually be selecting a face. You will be selecting actually a face which will be common to these two draft surfaces. So this face is actually common to these two draft faces. So the edges of this face means this edge and this edge will be used as the hinges. Draft hinges means this face and this face will actually be hinged or rounded about this. This face will be hinged about this edge, and this face will be hinged about this edge, and in this way they will be slanted. So let us click on, for example, this face. So here you can observe it here. So you can observe it here is, for example, I am changing like this. So this is actually the purpose of draft. So here you can actually input the draft angle, for example 15 degree or any suitable angle. So this face and these two faces have been drafted out here like this. So this is the simple demonstration. So you can actually include further faces as the draft faces as well. So let us edit in this. For example, I can include this bottom face or lower face as to be the draft face here, for example like this. So press control button from keyboard and bring the cursor here like this. For example, just RMB and click in from pick from list here, and here you can, for example, click on this face. So as you can observe, the bottom face has been highlighted. You just click on OK. So here you can observe that the bottom face is also being tapered or drafted, as you can observe it here. So again, for example, you can for example include that for this face here at this location in this background. So you can include that face as well. So click on this here, again bring the cursor here and just press control button from keyboard, and here RMB, and in pick from list go into, for example, click on this surface like this, click on OK. So here, so that means this face actually is actually the edges of this face are being used as the hinges for these four faces like this. So you can observe it here like this. So the maximum limit for this drafting angle is actually less than 90. Remember, less than 90. For example, you can observe it here any angle. For example, you can say, for example, let us do it 85. So let us just create OK. So here you can observe up to 85 degree angle it has been drafted out, but actually that is not the logical requirement. So that as usually you can say, for example, 20 to 30 degree drafting like this. Click on OK. So here you can observe that all four faces have been drafted out. So further in this way, so if you want for example, you have actually added the faces. For example, you can also remove the faces in the editing option. Here for example, I want to remove this face as the draft face, so I can remove. So you can individually remove as many faces as you want as the draft faces, and just click on OK. So in this way the draft can be controlled. So I think you have understood this feature, and this is very important. So you can actually widen this concept and further you can try it yourself. So let us delete this draft command as well. And after that, the very important thing is the command is actually the shell command. Shell command, as the name indicate, that it creates thin walled model like this. For example, I am just clicking on this face. So as you can observe it here, that this is the wall thickness, and remember the thickness has three options, means the whole thickness is actually added up inside, means half inside, half outside, or total outside like this, as you had actually observed in the thicken command in extrude option. So I had actually demonstrated this feature here, that this thickness, and here if you can, for example, I can make you understand here like this. So if you zoom in this portion here, so now you can observe it here, this in this way. So half thickness is added here in this direction and in this direction, and here you can observe the whole thickness has been added in the outer direction. Again click on it here like this. So there are three actually requirements for the thickness option. Whole thickness is added outside, half inside, half outside, and totally outside. So like this. So this is the simple demonstration for the shell command. And the other important thing is that go into the reference tab, so at least one face must be removed, otherwise it is like a shell model, means all the faces are actually closed and no face is removed. And here you can observe this is the removed surface, because if I am, for example, removing this surface, so actually this model has still shelled model, but actually it is just like a closed box. But if you want to remove some face, so you can click on this removed surfaces like this, and you can, for example, here you can observe I have actually increase the wall thickness or shell thickness. So here you can again observe the role for this thickness creation like this, means the whole thickness is now a half thickness is actually added in inside and half outside, and here the whole thickness has been added inside, and here like this the whole thickness has been added outside. So here whole thickness has been added outside, So here, like for example, look at from the top view. Here you can observe look at the difference. The whole thickness, because this is the outer model, the whole thickness has been added inside. Here half thickness added inside and half outside. So here actually you are observing that here are actually two options for thickness are actually being demonstrated, means whole thickness inside and whole thickness outside. Half thickness option is actually not being observed here. So in this way, this is the simple demonstration. So whenever actually we have logical requirement, so we can apply the thickness wherever it is required. So that is not a big task, so just for the time being. So actually the important thing is again go into the editing for this shell feature. So now the other important thing is that you can remove further faces, further surface. For example, I am adding, for example, I want to remove this face as well. So I will be pressing control button from keyboard and just bring the cursor here and click on it here like this. So this face has been removed. Again, for example, press control button and click on this face, for example, like this, and in this way, for example, click on it here, again here, and you can also, for example, remove this face, or you can select it using, you can say, quick select of quick pick option. This is very important thing. Again, click on it here, for example, like this, click on, press control button and now click on if you want to remove this face, just you can say pick from list here. So here, for example, this surface, now click on OK. So as you can observe it here, this face has also been removed. Again, for example, I want to remove this face, so bring the press control button and click on it here, and remember, right click and now again pick from list. Sorry, just a minute, just press control button. Actually selection and detection is very difficult. Press RMO, so sorry, pick from list here like this, this surface, now click on OK like this. So only one face is there, so that means but if you, for example, you cannot remove this thickness, so the model will not be existing there, so just click on OK. So leaving actually at least one face, you can remove all other faces. So in this way, again you can, for example, go into the editing mode and you can remove it here from as many surfaces as you want. And if you want to remove all the faces, you can simply remove all, click here like this, and it is a shell created. And again, for example, I am removing this face. So in this way This is the simple demonstration, very important. Like this you will be able to add or remove shell faces. So other thing is non-default thickness, so for the time being leave it, just a simple demonstration is sufficient. So after that, the next very important command is rib command that I will be demonstrating later on. So for the time being it is sufficient, just mark your attendance and demonstrate these command and write their methodology and send me a report within next 2 days. So thank you all. Assalamu alaikum. God bless you.